This playlist is your MFMQ Biology 1020 Summer 2018, or your most frequently missed questions from the semester, from our exams for Biology 1020 this summer. So here's how it works. For each exam, there were some number of questions that were what I call most frequently missed, meaning fewer than a third of students answered them correctly. Now, when that happens, I assume that there is a problem. Either it's a problem with all of you, or more than likely it's a problem with me, or a problem with the concept that I'm trying to teach, and I feel like I need to go over it again, and perhaps it wasn't a fair question or a well-worded question. So we review them, and then I take those questions out of that particular exam, which changes the denominator. So for example, exam 1 had 60 questions. This time around, there were 8, which were most frequently missed, which means the new denominator for exam 1 is 52. So when you took the exam the first time around, and if you got 45 questions correct out of 60, your score would have been 75% of the total. But with the new denominator, 45 out of 52 is actually 87%, so that's a big boost. So, another way that this helps you, besides removing those questions from those exams, is I bring them back on the final exam. And you know these questions are going to be there because I'm telling you right now that they will be in some type of form or fashion. You know to expect them. And since the final exam is worth more points, those questions should help you if you know that they're there and you understand the concepts, being well forewarned that they will be there. So a lot of times I get the question, what happens if I got one of these most frequently missed questions correct the first time? It doesn't matter. I don't change your numerator at all. So however many questions you got right the first time, that does not change. Your score will increase even if you got it right the first time. With that in mind, here are your most frequently missed questions from exam 1. 1 mole of water is approximately what volume? Now, in class, we did an exercise where I showed you how much a mole of water is, because I brought around a 50 milliliter vial that had 1 mole of water in it. How do you calculate the molar mass of a substance? Well, you have to know what the atomic masses are for the constituents. Water is H2O, so its molar mass is the mass of 2 hydrogen atoms plus 1 oxygen atom, which is approximately 18.1 Daltons per molecule of water. Remember, a mole is a number that fixes Daltons, or atomic mass units, to grams. And we also know that under biological conditions, or standard temperature and pressure, the density of water is that 1 gram is 1 milliliter. So therefore, a mole of water is 18.1 milliliters, or a little bit more than a tablespoon of water. Which of the carbon atoms in this molecule pictured below is asymmetric? I'm going to tell you right away that one of these is asymmetric. Answer E is not on the table. So you might have thought about the easy way that I told you to identify asymmetric carbons, that if you see any wedges or dashed lines, you know that is there to indicate that you've got an asymmetric carbon, and it's either coming out of the page out at you or going back into the page behind the plane of the sheet of paper or the screen that you're looking at. So, how do we recognize that a carbon is asymmetric? It should have 4 different substitutions. It should be bonded to 4 different atoms or molecules. So, any carbon that has a double bond is automatically not asymmetric. It's automatically symmetric because two of those bonds are being formed with one atom. So it can only have three different substitutions on it. So carbon A and carbon D are out. What about carbon B? Carbon B is attached to this carbon in a carboxyl group here, and this carbon, which is attached to all of this here. So those two are not the same, but it still has two bonds that are not drawn in, which are each going to a hydrogen atom, and those two hydrogen atoms are equivalent, so that carbon is not asymmetric. That leaves us with carbon C here. Carbon C, what are its four substitutions? It's got a hydroxyl group up here. It's got this carboxyl group over here. It's got a hydrogen that is not drawn on there, but we assume that it is there, since there are no double bonds. And then all of this, carbon B, carbon A, and the carboxyl functional group that is part of carbon A, that is all one substitution. So carbon C has four different substitutions. That one there. So that one is the asymmetric one. Okay, true or false, the linkages in starch and cellulose are the same, but the monomers are different. Actually, the opposite is true. Starch and cellulose are made up of glucose monomers, but they are linked together in different ways, and that is what gives these two plant-derived polysaccharides their very different functionality and their very different structure. Starch is very easily broken down by plants and by animals to be used for energy, whereas cellulose is a structural polysaccharide. It is formed in a way that makes it to last, be more permanent for the plant, form the cell walls, form wood, form paper, cotton. Those are all different forms of cellulose. So this one is actually false because the opposite case is true. All right, so which of these two molecules that I have here from our page of many molecules could be combined to form a triglyceride using 3 copies of one of these molecules? So first thing we should probably resolve and tell ourselves is, what is a triglyceride? What class of biological molecule is it? It is a lipid. Another name for a triglyceride is a fat. How do we make a fat? A fat is made from glycerol. So one of these molecules is glycerol, and 3 fatty acids. And fatty acids, as you may recall, have an acid functional group or a carboxyl functional group, like we see right here on molecule 4. And we see at the opposite end on molecule 5. So these are both fatty acids. So our answer has to include either 4 or 5. You can see that 3 of the answers have that. But which molecule is glycerol? Number 11 up here is glycerol. What does glycerol look like? It's a 3-carbon molecule with 3 hydroxyl groups on it. And each of these hydroxyl groups is able to join with the carboxyl group here to form what's called an ester linkage. So that's how we form a fat or a triglyceride. What are these other molecules? 13, this is a carbohydrate. You can see because it's got a carbonyl group in it as well as a bunch of hydroxyl groups. You should see that and think, aha, carbohydrate. Number 10 doesn't have as many of the atoms drawn in, but we should also recognize that this is also a carbohydrate. This is, let's see, deoxyribose, the 5-carbon sugar that's in DNA. Number 3, we look at that and we see this has a lot of nitrogen in it, a lot of amine groups. This is actually a nitrogenous base. It would be a pyrimidine because it is a 1-ring nitrogenous base. Remember, long word, short molecule, 1 ring versus 2. So the correct answer here would be C, 4 and 11. Oxandrolone, molecule 12. It is a controlled substance, which means you can't get it over the counter. It could be prescribed to you. It is a drug. What else do we know about it? And on the original exam, we had a bunch of Roman numerals in front of these choices, and then letter choices that said, well, maybe it's this but not that. So which of these things is it? Well, oxandrolone is in a class of molecules called steroids. It's actually an anabolic steroid, which is why it has the potential to be abused by people trying to gain muscle mass to get a competitive edge in athletics. What makes it a steroid is it has these 4 rings, 3 6-membered rings and 1 5-membered rings. And steroids are all classed as lipids. So whatever choice we have, it has to be both a steroid and a lipid. Is it a ketone? What is a ketone? A ketone is a carbonyl group that is C double bonded to O, but not with a hydrogen on that carbon. So if we look here on this particular O double bonded to a C here, this carbon has a bond to an O, a bond to another carbon, and then 2 bonds to this O. So that makes this a ketone. We also might recognize from the fact that the name oxandrolone ends in O-N-E, that suggests that it's a ketone. So 3 of these things are correct, which means we're leaning towards that last answer, all of these. But how is it an alcohol? Is any molecule that has a hydroxyl group on it. Here's a hydroxyl group up here. Now, even though it can be classified as an alcohol, that does not make this a water-soluble molecule. In fact, since it's a lipid, it is hydrophobic. It is fat-soluble. So there's our alcohol group. There's our ketone, which means that the correct answer is oxandrolone is all of these things. Okay, which molecule does not contain a carboxyl functional group? What does a carboxyl functional group look like? There are many different ways that you can see a carboxyl functional group, and they're all shown on here. Here's our fatty acid from a previous question. You can see it's got C double bonded to O, and then there's an OH on it. So it kind of looks like it's a carbonyl group and a hydroxyl group, but it doesn't act that way. Why not? Because since carboxyls are organic acids, it can donate this proton right here, to an aqueous solution. Alright, so we're going to look for number 4 does contain a carboxyl group. What about number 15 over here? Well, even though all of the carbons and hydrogens are not drawn in like they are in number 4, we should recognize that this C is double bonded to an O, and here's an O with a negative charge on it, which used to have a proton on it. So this is definitely a carboxyl functional group up here. But then there's another one down here at this end, this CO2 minus, that also represents a carboxyl functional group. Number 16 also has this CO2 minus on it, which hopefully now we recognize means that that is a carboxyl functional group. How about number 13? If number 13 does, then we're going to go with E. If not, we're going to say B. So we'll look and see, is there a carboxyl functional group? I see a C double bonded to an oxygen, but what else is it bonded to? It's between 2 carbon atoms, it looks like. So this is not a carboxyl functional group. This is a ketone functional group. So our correct answer is going to be option B, or number 13, which is a carbohydrate. No carboxyl functional group. This is molecule 15, which we saw on the previous slide. Which term does not describe this molecule? Well, let's see. Is it an ion? We see a full formal charge here, negative charge. It's a bit blurry because I blew this image up. Here's a positive charge, so yeah, it's 3 times an ion. Yes, yes, yes. Here, here, and here, 3 different charges on it. Is it an amino acid? Well, what are we going to look for? We're going to look for an amine group. That's what we see here, this charged amine group with the nitrogen in it. Does it have the acid group in it? Yes, we've already established that it does. In fact, it's got 2 carboxyl groups on it because this is an acidic amino acid because it has a second carboxyl group on it. Does it have an asymmetric carbon? Well, this one's an easy one to tell because it's got a wedge here coming out of the page and a wedge here going back into the page. And if we look at all 4 of the carbon of the bonds on this carbon atom, this alpha carbon, we can see that it has 4 different things and it's asymmetric. Alright, so is it D or E? Is there a ketone in here? Well, I just told you that this up here is a carboxyl functional group, not a carbonyl functional group. So it is not a ketone. Okay, what is the name of the process that occurs at 155 degrees Celsius where sugars and proteins form complex compounds which gives flavor and brown color to foods? This was a question from one of the supplemental videos, not one of the videos that I made, but one that was put together by the TED people, describing the chemistry of baking cookies. And this may have been the first time that you realize that any of those videos that I put into the playlist are subject to, you can be examined on those. So, this is the video that had this guy in there, this baker, and I'm going to link to that, and then after that video I will answer the question and finish off with the Unit 1 exam.